Line is in constant movement. Products are always coming and we are assembling those products. So we assemble those products with the tools. And to make sure that those products are perfectly assembled, we need to test those tools. And what do those tools actually assemble? They tighten, and they tighten joints. And these joints are really different types. Could you come a bit closer? When you look at this engine, we have joints in aluminum, in plastic, in steel, or different materials. And all of those materials, even some layers, all of them have really different characteristics. And it's really difficult to test this. And remember, the line is constantly moving, so I cannot actually run after that joint and test it all the time. So the best for me would be if I could actually simulate this joint. But as I said, they are different, and some of those joints, you know, I could simulate maybe with a joint like this one. It's pretty close to one over there, not identical. Sometimes this one is good. Sometimes could be something like this. It works, but it's not the same. The question is how to solve this problem. And the solution for this problem is the ST bench, a simulator of joints in your production. So we discussed about simulation of joints and how important that is. But in order to do a proper simulation of exact parameters of your joint, we need to have a quality system with strong hydraulics, with accurate transducers that give you 0.5% accuracy throughout the covered torque range. And with this, we can guarantee the best possible test of the tool with optimal conditions. And let's show how this actually looks like. Testing is as easy as pressing the play button. You simply choose the transducer that is suitable for the torque on your tool, and you can run the test. With hydraulic brakes, there is no need to untighten and retighten again. You simply continue tightening for the fastest and the most accurate test possible. And test is done. So, we discussed and explained how the bench works and why are we using it, how we are simulating the joints. But the question, and the most important one, is actually what can we test on the bench? What type of tools can we do and test on the bench? So let's say we start with the simplest one, the good old click wrench. Click wrench is probably the most difficult tool to test because it's so operator dependent. That's why on the ST bench we can have a special equipment on it that actually automates the process completely with no need for operator to in any way influence the measurement. And then let's move on. Let's say air tools. Those are pretty strong tools, fast tools, and sensitive transducers could have a problem with those. That's why for this type of tool we can install static transducers on the bench so that we can even measure a tool like this. And then maybe moving to something that is more often seen in modern production, like a classic angle tool. These can be handled and measured with the bench with no issues. Another shape that is a really specific when we are testing tools is a pistol tool. A pistol tool, it's easy, practical to use, but when you think about the bench and how we saw it, testing it like this is not really ergonomic. That's why we are able to lift the table with the brakes and actually test the tool vertically, like is the natural position for this. But bench as it is not limited just to standard tools. We can handle some pretty specific tasks. Let's say a tool like this that requires a special attachment to be built so that you can actually test it. But for bench, this is not a challenge and it can be easily handled. every production is different. So the bench needs to be a very versatile device that can be easily adjusted to your specific needs. So whether you're using low torque or high torque, whether you are testing some manual tools, so you need some special equipment to do this, or maybe you have special or different types of tools. So then, of course, it's always good to have all the attachments that you need in order to test your tools ready. Maybe you have a specific application in your production that's actually outside the scope of the torque range of the bench. Then it's possible to use external transducers that you can connect either through cable using the connectors on the side, or you would use wireless transducers and connect directly to the interface of the SD bench. Sometimes even you have an application that is at the place of the factory where you cannot even reach with the bench. Then you can actually use the interface of the SD bench called the SD pad, take it with you and go to the place where you can test and use the wireless transducers to do it. We discussed about the SD bench and how we can test the tools on the SD bench. At the same time, I showed you that a user interface of the SD bench can also be removed and used for testing in the parts of the factory where SD bench cannot access. And the device that we are using to provide this functionality is the SD pad. So it's a practical device, a versatile device that can be used for many different applications. It can store all your data, all your programs, help you see the graphs for better analysis, provide even visual guidance for you to show you how to do, let's say, more complicated and challenging tasks. At the same time, one of the crucial parts of this system is the wireless communication with the transducer. A system like IRC-Connect connected with the IRTT transducer that can enable wireless communication. At the same time, IRC-Connect has internal memory that prevents any kind of data loss in case of any reason that we lost this communication. One of the challenges that we can really successfully solve using the IRC-Connect with a combination with the IRTT is the control and measurement of angle. So torque is one thing, angle is another challenge. Let me show you. We have IRC-Connect here connected to the transducer IRTT. During normal tightening, you would have a situation like this. You have a system that is rotating, sometimes less, sometimes more. This creates problem with angle measurement. How we tackle this challenge? We added a gyroscope to the IRC-Connect, which can actually compensate for this movement and make sure that it always reads the correct angle. And in this way, enabling you to do some more advanced checks, let's say torque plus angle. Both of them, or this kind of application, could be precisely measured with this system. Another advantage of this system, considering it's a wireless solution, is the ability to control fixed stations like this one here. It can save your time, especially you don't have to disassemble the system. You can measure it in this way. Or let's say you have a robot station, so it means limited access. You cannot be there while it's operating. So installing a transducer like this, getting out of this protected area and running the test, it's a simple task. Till now we talked about functionality that only controls and checks tools. So in Atlas Copco terminology, we call this a tool check functionality. But there is another aspect connected to the joint that is really important for the behavior and the stability of the process, and that is the torque that is left in the joint after the tightening, a residual torque, and we call this functionality a joint check functionality. So here we need to check what torque is left in the joint after the tightening. And again, we can use the SD pad for that application. SD pad now not connected to a transducer like the IRTT, but connected to a device like SD wrench, which can actually measure this residual torque. One of the great advantages of ST wrench is that it has a patented algorithm which can measure the residual torque, minimizing the influence of the operator, and of course removing all other aspects in the joint, but only reporting the torque value. This application and this process is not always the simplest one to do, and that's why having the option to have an operator guidance, a system that can guide you through the steps, finding you and helping you to locate the joint, maybe even showing you a video on the screen of the ST-Pad device so that you can really know what you need to do. And of course, this information is transferred automatically from ST-Wrench to ST-Pad and afterwards to software QA Supervisor that can actually handle and analyze all the data from your production. ST-Pad is a part of QA Platform 4.0. So for us, it's not just a tool to measure torque. It's not just, really narrow field of quality in your factory. When you think about quality, it's not only about torque in this joint. It's an important part, but also all of these parts need to be assembled with other parts. So it means you have some dimensions, tolerances that you need to maintain in order to be able to install your products further down the line. And for this, we implemented a next strategy for control of quality, and we call it dimensional check. So here we can use devices, let's say like this caliper, to measure data. And here we are moving away from the standard way of working with devices like this, where you record everything right down on paper, and then maybe later on transfer this information into some Excel file or database. So we automated this process with using the Bluetooth communication that these devices come with, and integrating it with the ST-Pad, we can actually automatically transfer the data and have a test with information, clear information on what needs to be measured, measure it, and send the data to the ST-Pad. And after that, all of this data is processed, statistically checked, and sent to a database, which is a QA Supervisor software. Production is not always ideal, and you don't always have the perfect controlled environment where you can actually do your checks and control. Sometimes you need to go on the production line next to the products and work there. So having a device like ST-Pad could be maybe an issue because of the size. For that, we can use a more practical, smaller device, ST-Palm, where you can have the same functionalities you have on the ST-Pad, but in a smaller, more practical format. Maybe carry it as a phone on your hand, like when running, so you have both hands free and you can do your tests in the optimal way. Till now, we discussed about how to do QA in the production itself. Another important part of QA is the data analysis. So how to work with all the information that we gathered. And when you now think about, let's say, Industry 4.0, the same thing is coming to QA, and it's here already. So a lot of devices, everything is collecting some sort of data and then putting it all in one database. This actually creates some challenges. And we created a solution to help you actually work and organize the QA process. And our solution for this is QA Supervisor. It's a server-based solution, so it means you can access it from any computer, tablet, whatever is best for you. You can reach it from any part of your factory or maybe from some office, lab where you are doing your tests. You can reach it from the factory where you need to change sets, to update programs, whatever. And you can, of course, use it to communicate with other parts of your factory, let's say maintenance. But let's take a look what it can actually do. Once you log in to the QA Supervisor software, you will see a screen with a quick overview of the situation in QA. And this screen can be customized to information that only you are interested in. So it means I'm an operator and I'm, let's say, responsible for a specific part of the factory. So I would define this in my settings, and once I log in, the dashboard of the software will show the information that are relevant to me. So it means every user can have a different overview based on their responsibilities. Let me summarize main points of the QA Platform 4.0 and our software solution, QA Supervisor. QA Supervisor, as I said, is a server-based solution, so it's easily accessible throughout your factory. It offers a database so that you can store all your QA data. It gives you a dashboard with a quick overview of the QA status. It has a tool database, so you have an overview of all the tools that you are controlling. Every tool can have an inspection assigned, and this inspection can be connected with scheduling so that you make sure that you always do a check of the tool on time. On the other hand, we can provide a solution. We call that a route. So it's like a package of inspections that you just put a filter on. Let's say on every Monday, I will send inspections that will expire within next 7 days to my team. That means on Monday, they receive their tasks. They have a week to do everything, and you make sure that no inspection is ever late. If you are interested in more deeper analysis of your results, you can, of course, upload all results to QA Supervisor software, and there we can analyze individual curves, or even if needed, we can put those curves in one graph and compare those results. So within the results section, we find our results. We can take a look at the individual points. We, of course, have a statistical analysis with the final result of the inspection, but we can, of course, check the data or check the traces and simply place several curves over each other on the same graph, enabling us to compare them, zoom in into specific areas to have a more detailed view. And of course, we can create automatic reports so that you can create a report based on this inspection when you need it. So no need to prepare them in advance, store them in some warehouse in paper form. They are always available whenever needed. Today I showed you the overview of our platform, but we all know that QA is much more complex than this. So please contact us to discuss details.